Hey there, Chem Squad. In today's class, we're going to look at something called the electromagnetic spectrum. This has a lot to do with physics, but again, we're looking at it from the chemistry aspect. So one of the first things that I'd like to talk about is the idea of light. So the word light is basically made up of particles called photons. Okay. So a photon is essentially what light is made of. Okay, and most of the time, light is emitted by atoms, okay, and objects through chemical reactions. But before we get into all of that, we just have to understand what light is, how it travels, and how we actually see and visualize light. So if this round circle is a photon does have mass. Okay, it is actually heavier than something like an electron. But in space, okay, so let's say light coming from the sun, there's two rules of thought in terms of how it travels through space. Okay, sometimes we see photons travel in a straight line. So photons can travel in a straight line called a ray. Okay, so going from one end to another. The other way that photons can travel is through the motion of waves. So here it travels as a wave. Okay. Both means of travel are observed. Okay. So we say that sometimes we see light traveling as rays, sometimes we see light behaving differently and travel as waves. All of this happens in space, okay, and as well as on our planet, especially when light is occurring within our atmosphere. But we don't see all types of light. Okay. Light, quote unquote, is made up of different parts of the electromagnetic spectrum. Okay. Sometimes it's called radiation. Or different types of radiation. Now, we don't use the word radiation that much because a lot of the times people have a negative viewpoint in terms of radioactivity, but not all radiation is bad. Okay? It just depends on how long or short these wavelengths are. So, for example, you're going to need a bit of space here, and I will certainly try to fit it in the screen here. But you're going to drop about maybe 2 or 3 lines, And we're going to go from one end of the screen to the other, like this. We're going to have a point right in the middle here. Okay. And we're going to have a whole bunch of other points along this spectrum, okay, along this timeline. So in the middle here, we're going to start off with the section of this electromagnetic spectrum that we can see, that humans are able to observe. This is called visible light. Okay, so I'm going to move up just a little bit. In terms of what you see as light, you actually see colors. And there is an acronym that is used to show people how you can memorize all the colors in order. And that acronym is Roy G. Biv. Okay. What Roy G. Biv stands for is your colors of the rainbow. So you have red, you have orange, yellow, green, blue, indigo, and violet. Now all the colors except for indigo are actual true colors that you're familiar with. Indigo they put in so that they can use the acronym Roy G. Biv, otherwise it'll be Roy G. Biv. So they just put that in there to make it better sounding. But Roy G. Biv is what it is. It's all the different colors or rainbows of light that you are able to see. And we can tell that this exists because if you shine a light through a prism, right, white light going in through a prism will split up into all of these colors. Okay, so that white light that you see is actually visible light. Okay, it's just a blend of all these colors. So if you understand that visible light is the only light that humans can see, then everything else on the right of the spectrum this way and everything on the left of the spectrum are typically radiation that you cannot see. So let's look at what happens when we go towards the right first. Okay. At this point here, you have ultraviolet. Okay, this is the ultraviolet end, because when you go from red to violet, violet is the last color in the visible light spectrum. The next one over is ultraviolet. Okay, and this is basically UV rays from the sun. So example, sunlight. Okay. Now, we know that if you stay out too long in the sun, your skin will eventually get burnt. Okay, so ultraviolet light is damaging to human tissue. If we go even further towards the left, we hit X-rays. Okay. X-rays are also damaging for humans. Okay, and we produce X-rays through an X-ray machine. You'll notice that the people, the lab technicians who work with X-rays, they're usually wearing a lead-lined apron or they're in a separate room. Okay, they're not standing right next to you and the machine when they're taking the X-rays, because when they get repeatedly exposed to X-rays, it can be dangerous for their tissues. But if you're just lying there getting X-ray taken once, okay, there's very little harm being done to you. If we go a little bit further along the spectrum, you'll eventually hit gamma rays. Okay. Gamma rays is basically the radioactive material that we think of. Okay, so example, radioactive elements. Okay, radioactive elements can produce gamma rays. Over a little bit more, you might even get something called cosmic rays. And here it's just the radiation that you find in space. So alpha particles, beta particles, and things like that, those would all be classified under cosmic rays. So essentially, this whole gamma rays, cosmic rays situation, very dangerous for human tissue. Okay, so the reason why they're dangerous is because at this end here, you actually have very short wavelengths. So if you remember, light can travel in waves. So a short wavelength means their motion is very compact like this. Okay, so the shorter the wavelength, the more energy is packed into those wavelengths. Okay, so at this end here, we have high energy. And because it's high energy and they're short wavelengths, they're quite damaging to human tissues and cells. So if we go on the opposite end, okay, we're heading towards the longer wavelengths. So the one that is right before visible light is something called infrared. Okay. Infrared light you cannot see. There are some animals that can see infrared, as well as there are some animals that can probably see ultraviolet. Okay, but humans cannot see infrared. Infrared things come from things like remote controls. Okay, so whether it's a TV remote, so let's say TV remote, okay, they use infrared. Body heat is close to the infrared range. Okay, it's actually somewhere between infrared and the next one over here, which is microwaves. Okay. So microwaves, of course, naturally you would find them in microwave ovens. Okay. So sometimes I know growing up, my parents never really liked the microwave because they always say, "Oh yeah, it has radiation. Okay, it leaks radiation. It could be damaging to your cells." Well, if it's all the way on this side of the spectrum, right, past visible light, or sorry, before visible light, if colors of light can't hurt me, okay, and a TV remote can't hurt me, microwaves, okay, the radiation from microwave ovens would also be harmless to me. Okay, so let's see. In between that, I apologize for running out of space. Maybe I'll just rewrite it here. So microwaves. Okay, over here we have cellular waves. Okay, and at the far end we have radio waves. So again, the examples are kind of obvious. So you have radio signals and you have cell phones. right? So these waves here are very long waves, right? So they have a long wavelength. So visually, you would stretch out the wave so that they're much longer. And longer wavelengths are low energy. Okay. Low energy wavelengths aren't as intensive, so it doesn't really harm human tissues. You can be exposed to radio waves, cellular waves, microwaves, infrared heat. The amount of damage is low. The only time when these waves could possibly be dangerous is if you were exposed to it for a very, very long time, okay, or perhaps repeatedly in a short period of time. So basically anything that we have here, okay, this makes up the entire electromagnetic spectrum. Now I'm not going to go into the actual size of the wavelengths, but some of the long wavelengths, they basically have distances that cover, kilometers, and the short wavelengths, okay, cover nanometers. Okay, so they're very, very short and tiny, and packed with energy. So hopefully this gives you some idea in terms of what the electromagnetic spectrum is about. Um, this lesson is kind of the precursor to what I'm going to show you in class regarding how atoms can emit light. Okay, in particular things like materials that glow in the dark. Okay, so in order to understand how that works, I need to have gone through the electromagnetic spectrum with you guys. All right, thank you for your time. Take care.